Hello my dear friends, welcome back to our YouTube channel. This is your ADC Max. We have seen so many methods to determine the inverse Z transforms, namely convolution theorem, residual method, long division method, are called power series method. So this is the one more technique to find the inverse Z transforms by using method of partial fractions. So the method of partial fractions is one of the very general method. We can easily find out, we can easily apply this technique for any types of problems to determine the inverse Z transforms. It's clear? Now I would like to go for the method of partial fraction, but before going to that, the condition for the method of partial fraction is the degree of the numerator. The degree of the numerator term should be less than the degree of the denominator. So degree of the numerator is strictly less than the degree of the denominator. So that's the only condition to apply the method of partial fraction. Okay. So you can go for the first question. Find the Z transform of Z by Z squared plus 7Z plus 10. So what is the ultimate aim for this method is, first of all, resolve into linear factors. We can resolve the given term into the linear factors, then take the Z inverse, we get the required answer. So in this question number 1, obviously this is my x of Z, right? So what is Z inverse of x of Z? Is nothing but x of Z. So that is my requirement. Now I am taking that x of Z by Z. So I reserve one Z. I reserve one Z in the x of Z. So x of Z by Z is equal to 1 by Z squared plus 7Z plus 10. So let us split up this into two separate linear terms. So the sum of the root is plus 7, product is 10, I think 2 and 5. So this can be written as Z plus 2 into Z plus 5. So 2 plus 5 is 7, 2 into 5 is 10. So that's right. Now by the method of partial fraction, what it says that, let us introduce the arbitrary constants to each linear factor. Otherwise, to introduce the arbitrary constants to equal to the degree. What is the degree of this denominator? 2. Degree of the denominator is 0. So this obviously fulfills the condition. So the degree is 2. That's why we get 2 linear factors. So I introduce 2 constants to each linear term. So one for Z plus 2. So A by Z plus 2 and B by Z plus 5. Right? Now, once we get this to determine A and B values, once we determine these two constants A and B, then obviously that is my requirement. So, what I am going to do that, I can take this part now, yes, right? I'm going to take the LCM of this side, what happened? In the left hand side, 1 by Z plus 2 into Z plus 5, is right? Is equal to. We take the LCM of the right hand side, then we get this Z plus 2 into Z plus 5. Let's cross multiply this, we get A into Z plus 5 plus B into, let's cross multiply to this, we get Z plus 2. So that is the, now the both the left hand side and right hand side denominators are same. So let's cancel it. We get 1 is equal to A into Z plus 5 plus B into Z plus 2. Our ultimate aim is to determine these two arbitrary constants A and B. So what I suggest you that, so whatever we have the factors Z plus 2 and Z plus 5. So Z plus 2 is equal to 0. What about Z minus 2? Z plus 5 equal to 0, we get Z is equal to minus 5. So once we substitute Z equal to minus 2 and Z equal to minus 5, we will get the required constant, because when I substitute Z equal to minus 2, this term becomes 0. So B becomes 0, B vanishes. So we get the A value. Similarly, when I substitute Z equal to minus 5, A term becomes 0. So we get the B value. So that's a simple case, right? So when Z is equal to minus 2, what happened? Substitute Z equal to minus 2, the left hand side there is no Z. So 1 is equal to minus 2 plus 5. So A into minus 2 plus 5. So is equal to 1 equal to 3A. Otherwise A equal to 1 by 3. So I got the A value in the first value of Z plus 2 is equal to 2. That's why Z equal to minus 2. The second linear factors, we get Z is equal to minus 5. Now substitute Z equal to minus 5. This time A becomes 0. What about this, the previous case? When I substitute minus 2 plus 2 0. So B becomes 0 there. Yeah, now this time when it's equal to minus 5 plus 5 is 0, 0 by A is 0. So left hand side is 1 because there is no Z at all. Right-hand side minus 5 plus 2. So b into minus 5 plus 2 is equal to 1 is equal to minus 3b. Otherwise b is equal to minus 1 by 3. So once we got the a and b value, let us substitute a is equal to. So x of z by z is equal to, what is it? A equal to 1 by 3 by z plus 2 plus minus 1 by 3 by z plus 1. Is it? It's clear? Now, this is a 1 by 3 minus 1 by 3 is a common constant. Let's take the outside and send it cross multiplying the z to the next side. So what happened? So 1 by 3 taken outside. The balance is z by z plus 2. Clear? Then this is 1 by 3 taken outside now. So minus getting down and z multiplied to the next side, we get z by z plus 5. So this is my x of z now. Now taking the z inverse on both these sides. So z inverse of x of z is equal to, by using the linear property, this is 1 by 3 taken outside. So z inverse of z by z plus 2 minus z inverse of z plus 5. It's clear? Alright? So what is the z inverse of z minus 2? If you know this result, so z transform of a to the power n is equal to z by z minus a. Then what about the z inverse of z by z minus a is equal to a to the power n, isn't it? So what's the reason of validity here? Mod z is greater than mod a. So once if we know this result, we can easily get the answer. Now what about the a in this first term? A equal to 2. The second term, a is equal to, I think it's plus 2. So minus 2, a equal to minus 5. So a equal to minus 2 and a equal to minus 5. So by using the last step, what we'll get? So 1 by 3 is already there. So z inverse of z by z plus a. So here minus a means here plus a. Here plus means it's minus. So it is minus 2 whole power n. Then this minus, yes. Here a equal to minus 5. So minus 5 whole power n. So this is the required x of n. This is nothing but the required z transform of x of z. So let us continue with that. So this is the inverse z transform by using the method of partial fraction. So but even though you should know this result, unless otherwise you can't able to get this inverse z transforms. But once we can split up into two linear factors, let us apply the inverse z transform by using the linear property, and with help of the standard z transform techniques we will get the answer. So that is the first sum. Okay. Let us see the second problem. I have considered the second problem is z inverse of z by z plus 1 into z minus 1 to the whole square. Z minus 1 to the whole square. So can you see the what's the degree of the numerator? It is 1. The degree of the denominator is 1 plus 2, which is 3. So we apply the method of partial fraction. Let us consider this is my x of z. Now to reserve one z from the numerator side, which will give 1 by z plus 1 into z minus 1 to the whole square. But anyhow, what's the degree of the numerator? 0. Denominator is 3 only, so we can easily apply the method of partial fraction. And can you tell me what is the degree of the denominator? 3. So 3 means we have to use 3 arbitrary constants. 3 arbitrary constants. So for the number of degrees is equal to the number of arbitrary constants. So let us apply the method of partial fraction to this term. To the first linear factor z plus 1, we introduce one constant. So z by, that is a by z plus 1 for the first constant. But the z minus 1 is repeated twice. So I need to introduce two constants only for this factor z minus 1 whole square. So how to introduce the constant? So I introduce the first constant for z minus 1 whole power 1 because it is twice. So for the first time, for the first degree, we introduce one constant. For the second degree, I introduce the second constant. So anyhow, totally there are two constants for this term z minus 1 because z minus 1 is repeated twice. Suppose z minus 1 is repeated thrice means we go for the third one, d by z minus 1 over 3. So for each degree, we introduce one constant. So there is a concept behind the method of partial fraction. The same idea, let us take the LCM. So 1 by z plus 1 into z minus 1 to the whole square. Let's take the same LCM, z minus 1 into z minus 1 to the whole square. Very simple concept. What is the term is available in the denominator of a, z plus 1. So what's the balance? Z minus 1 is missing. So z minus 1 whole square is missing. Plus. Now b. Under the b, z minus 1 is present. So only one power is present here. What's the balance missing here? Z plus 1 into one more z minus 1 is missing because z minus 1 is there. And z minus 1 whole square. So one term is missing. And third one z minus 1 square is present. So z plus 1 is missing. So z plus 1. So this is the way to just take some LCM. Cancel the both the left hand side, right hand side. So 1 equal to Z A into Z minus 1 whole square plus B into Z plus 1 into Z minus 1 plus C into Z plus 1. So once again what I say, there are two factors here. One is Z plus 1. If I make it 0, we get Z minus 1. And the other one is Z minus 1 equal to 0, that means we get Z equal to 1. So there are two possible cases. So when Z is equal to minus 1, what happened? When Z is equal to plus 1, what happened? So by using the minus 1 and for the plus 1, we will easily get the two constants among the three. To find the third one, how to get the third one? Let us choose Z equal to 0. So this is the third possible case. If you substitute Z equal to minus 1 in the left hand side, no changes. So minus 1, minus 1. So A into minus 1, minus 1 whole square. What about minus 1 plus 1? 0. So this term is completely 0. Minus 1 plus 1, 0. So this is obviously becomes 0, the other two terms. So what about minus 1, minus 2? So minus 2 whole square. So minus 2 whole square plus 4. So 1 equal to 4A, otherwise A equal to 1 by 4. Similarly, what about when Z equal to plus 1? When Z equal to plus 1, the left hand side is 1 and 1 minus 1, 0. So A into 0, A becomes 0. Here also we have 1, 1 minus 1, 0. So B is also 0 this time. Here we get 1 plus 1, 2. So we get 2C. So C is equal to 1 by 2. So I found that A and C value. To get the B value, very simple case by putting Z equal to 0. When substitute Z equal to 0, left hand side is 1. When putting Z equal to 0, we get A into minus 1 whole square plus B into Z equal to 0, Z equal to 0, plus 1 minus 1, plus 1 into minus 1, plus C into plus 1. So by this way we get A equal to this A minus B plus C. So minus B to bring up to the left hand side. So this is the remaining is A plus C minus 1 because this one goes to that side. Now A equal to 1 by 4, C equal to 1 by 2. So A equal to 1 by 4 plus C is equal to 1 by 2 minus 1. I think 1 by 4 plus 1 by 2 is 3 by 4. So 3 by 4 minus 1. How much? Is equal to 1 by 4. So B is also 1 by 4. B is also I think minus 1 by 4. Yes, minus 1 by 4. So once we got the A, B, C values, let us substitute in the place of A is equal to 1 by 4, B equal to minus 1 by 4, C is equal to 1 by 2. So what happened? So this X of Z by Z is equal to A is equal to 1 by 4 by Z plus 1 and B is equal to minus 1 by 4 by Z minus 1 and plus C is equal to 1 by 2 by Z minus 1 to the whole square. Yeah, it's very important. Z whole square. Yeah, now let's multiply Z to the next term. So X of Z becomes 1 by 4 into, by using the linear property, so Z by Z plus 1, yes right, minus 1 by 4 into Z by Z minus 1, is clear, and finally plus 1 by 2 into Z by Z minus 1 to the whole square. Now my aim is to get the Z inverse of, so now taking the Z inverse of X of Z, because X of Z is nothing but this one. So Z by Z plus 1 into Z minus whole square. So this is the X of Z. Now let us take the Z inverse. By using the linear property we get 1 by 4 into Z inverse of Z by Z plus 1 minus 1 by 4. This is a constant term by using the linear property. Please go and watch a separate video I made for the linear properties and the Z transforms. Z by Z minus 1 and finally plus 1 by 2 into Z inverse of Z by Z minus 1 whole square. Now in this step what I am suggesting that unless otherwise if you get up to this is well and good, but hereafter what will be the Z inverse? Unless otherwise it doesn't know this result, you can't able to get the answer for this one. But even though let us say that Z by Z plus A, so here A equal to minus 1, right sir? A equal to minus 1, here A equal to plus 1. So can we use this result, we get the Z inverse of, that is 1 by 4 into here A equal to minus 1, so minus 1 whole power n is right, by using this result. Here A equal to A, minus n is plus A, here A equal to minus 1, here minus 1 by 4 into, here A equal to plus 1, so it is 1 power n. But there is no result associated with this one. So if you, unless otherwise, if you know this result, what's the Z transform of n square? Z transform of n square is Z by Z minus 1 whole square. Z transform of n, yeah, Z transform of n is Z by Z minus 1 whole square, then you get the Z inverse. What's Z inverse now? Z inverse of Z by Z minus 1 to the whole square is nothing but n. So if you don't know this result, sorry, you can't able to get this, the last term. So that's why I am saying that there are many techniques to determine the Z inverse. But one and only method which will give the answer directly to you without any basic knowledge, without any basic Z transform, that is called residue theorem. So please go and watch the residue theorem. That's a very interesting, very easiest one which will give the answer directly without knowing this type of standard Z transform results. So what's the last one? 1 by 2 into. So what's Z inverse of Z by Z minus 1 whole square? It is n. So this is my required, the Z inverse of the given function. So this is the answer. X of n is equal to 1 by 4 minus 1 whole power n minus 1 by 4 plus 1 whole power n plus 1 by 2 into n for n equal to 0, 1, 2, 3, etc. etc. Right? Now the third one is Z inverse of Z squared by Z minus A into Z minus B. I think so I did the same question by using the conversion theorem. And even though by using the residue theorem. Please go and watch it. The same question, the same thing. I think I found the answer is A to the power n plus 1 minus B to the power n plus 1 by A minus B, provided the condition is mod A is greater than mod B. I did the same question under the by using the conversion theorem and the residue theorem. But this time I would like to use the method of partial fraction. So what will happen? You get the same answer or not? I don't know exactly. But anyhow, I hope that I may get the same answer. Let's see how. Let us see how I am getting the answer for this question by using the method of partial fraction. Let us see. Yeah. So this is my x of z. As I told you that, can you reserve one z into the left hand side? So x of z by z is equal to z by z minus a into z minus b. So it is already in two linear factors. The degree of the numerator is 1, denominator is 2. So we can apply the method of partial fraction. So I introduce capital A is equal to for a minus b, so z minus a, for b for z minus b. So can I take the LCM of this side? What happened? We get is z by z minus a into z minus b, and in the left hand side, okay, the right hand side, can we take the z minus a into z minus b as LCM? This cross multiplying this, we get a into z minus b plus b into z minus a. So after cancellation of this, we get z is equal to a into z minus b plus b into z minus a. So there are two possible cases when z is equal to minus a plus a. What happened? When z is equal to plus b, what will happen? Yeah, because z minus a, z minus b is the factor. So z minus a equal to 0. So z minus a equal to 0 means z is equal to a. Similarly, z is equal to b. So when z equal to a, what happened? Left hand side is a. So capital A into a minus b. What about a minus a is 0? So b into 0, that is a by small a by a minus b. So this is the small a value. When z equal to b, this time b becomes 0. The left hand side is z. Z equal to b minus b 0, b minus a. So b into b minus a. So for my convenience, I can write this by b minus a, but unfortunately this is a minus b, so I can reverse right. I can write that term reverse. So b is by minus b by a. So let us substitute. And this step, what happened? We get this x of z by z is equal to, I think, a by a minus b by z minus a, right? Minus, I think this minus is getting down here. So minus b by a minus b by z minus b. Is clear? So this is nothing but x of z. Can I multiply the z to the next side? So a by a minus b into z by z minus a minus b by z minus b into z by z minus b. Now multiply this reserved z to the next side. Now take the z inverse on both these sides. So by using the linear property, this a by a minus b into z inverse of z by z minus a minus b by a minus b into z inverse of z by z minus b. So by using this result, is nothing but z inverse of z by z minus a equal to a power n, and this b power n. So this is comes a by a minus b into a to the power n, right? Minus b by a minus b into b to the power n. I think so. Same powers. So let's multiply this. We get a to the power n plus 1. The denominator is same, a minus b and minus b power n plus 1. I think so. I get the same answer. Yeah, a power n plus 1 minus b power n plus 1 by a minus b. So when we get the same answer, whenever we can take the Z inverse by using the convolution theorem, or maybe the method of partial fraction, or even by the residue theorem. But in the residue theorem we get the answer directly, but in this case you should know this Z inverse transform, the results, otherwise you can't able to get this answer, right? Understand what I am saying there? Let us see the another problem in this model method of partial fractions. Is the inverse of z into z plus 1 by z minus 1 into z squared plus 1. So this is my x of z, and so what's the z inverse of x of z? Nothing but x of a. So I can reserve one z to the left hand side along with the x of z. So z plus 1 by z minus 1 into z squared plus 1. The degree of the numerator is 1, denominator is 3. So by that good we can apply. But z squared plus 1. Z squared plus 1 can be split up into two factors. So how we can do that? So this is equal to, for example, it's z plus I into z minus I. So this looks like a plus b into a minus b model. What's a plus b into a minus b? A squared minus b squared. So it's equal to z squared minus of I to the whole square. So z squared, what's the minus of minus 1 is equal to plus 1. So that is z squared plus 1. So this is the two factors for that term. So let us rewrite z squared plus 1 by z plus I into z minus I. Now there are three linear factors in the denominators. So let us introduce three arbitrary constants. The a for z minus 1, b for z plus I, c for z minus I. So after taking the LCM, cancelling it, what we'll get? Left hand side z plus 1, the right hand side a by. So z minus 1 is there. So z plus I, z minus I. Yeah. And b is there. So b is z plus 1, so z minus 1 is z minus I. c by z minus I is there. So z minus 1 is z plus I. So there are three possible cases. Z equal to 1 minus I plus I. Substitute z equal to 1, we will get it is these two terms become 0. 1 minus 1 0, 1 minus 1 0. So this b and c become 0. This becomes 1 plus I and 1 minus I is nothing but 1 squared minus I squared. I squared is minus 1, so plus 1. Minus 1 minus plus 1. So 2a equal to 2. So a equal to 1. Similarly, we are putting z equal to minus I. What we will get? I think minus I plus I 0. Minus I plus I 0. So this a and c becomes 0. This term is minus I minus 1, minus I minus I. So minus 2i here, and take minus n outside, we get 1 plus I. Now let us multiply the 1 plus I along with the 2i. 2i into 1 is 2i. 2i into I squared is minus 1. So this becomes minus 2. Taking 2 outside, we get 1 minus I. So this 1 minus I, left hand side 1 minus I will cancel. So 1 equal to minus 2b, b equal to minus 1 by 2. Similarly, when z equal to plus I, the same concept, when z equal to plus I, we get the left hand side is I plus 1 or 1 plus I. So I minus I 0, I minus I 0, we get here I plus I 2i, I minus 1 into c. So here by taking multiplying 2i into the term, I into I square is minus 1, so minus 2, minus 2i. By taking minus 2 outside, minus 2c into 1 plus I. So 1 plus I get cancelled, so c is equal to minus 1 by 2. Now this step becomes x of z by z is equal to a equal to 1, so 1 by z minus 1, and b, what's the b here? Minus 1 by 2. So minus 1 by 2 plus by z plus I. And c is also minus 1 by 2 by z minus I. Now multiply the z to the next term using the z inverse, we get the answer. So let us see that it is z by z minus 1, right? Minus 1 by 2 down. So z by z plus I. Here, then minus 1 by 2 into z by z minus I. So let us take the inverse z transform. So let us take the z inverse, and both these sides we get z inverse of x of z is equal to, so z inverse of z by z minus 1 minus 1 by 2 into z inverse of z by z plus I minus 1 by 2 into z inverse of z minus I. So as already we know that the z transform of a to the power n is equal to z by z minus a, otherwise z inverse of z by z minus a is equal to a power n. Now by using this idea here, I think so. What is this one? If you remember, what's z transform of 1? Very first result, z by z minus 1. So z inverse of z by z minus 1 is equal to 1, isn't it? Right? So the final answer is 1 minus 1 by 2 into, I think so, the plus I means minus I whole power n by using this result. And here is a equal to I, so it is minus 1 by 2 into plus I power n for I is equal to 0, 1, 2, etc. etc. So this is the required the z inverse transform of the x of z by using the method of partial fraction. So let us see that we have seen almost varieties of problems under this method of partial fractions. So the idea is very simple. I want to resolve it, the given terms into the linear factors. But before going to apply the method of partial fraction, check the degree of the numerator should be strictly less than the degree of the denominator. Is right? Then take the Z inverse, we will get the answer. So this is the idea behind this inverse Z transforms by using the method of partial fraction. So I hope everyone is understand this concept. Please kindly go and watch the other methods too, because there are nearly 4 methods including this one, method of conversion theorem, method of partial fraction, the second one, and long division method, and the residue theorem. So all are the different techniques, but among the 4, the residue method is very easy one. The other 3 is also right, but unless the case if you know this result, then it's well and good. Okay, I hope everyone is enjoyed this video. Please kindly subscribe, support to our YouTube channel ADC Max. Thank you, take care, bye. I am signing off you. Thank you.